Congratulations on your purchase of the AccuTurn Model 8922 Combination Brake Lathe. The 8922 Combination Lathe will machine most passenger car and light truck rotors, drums, and flywheels with the standard accessory group. This massive 450-pound lathe, with its 6-inch wide adjustable dovetail ways, is capable of machining most workpieces in a single pass, regardless of depth of cut. Since its introduction in 1984, the AccuTurn brake lathe has become the leader in the industry. There is no other lathe in the world today that can equal the AccuTurn lathe in performance, accuracy, and surface finish. Many of today's leading vehicle manufacturers specify the AccuTurn brake lathe, and their testing of the AccuTurn lathe has proven that their dealerships will produce superior brake service, have far less comebacks, and most importantly, their vehicles will stop quicker. Now let us show you how to get the best performance from your AccuTurn brake lathe. There are two basic types of rotors, hubbed and hubless. We will first address the hubless rotor. The hubless rotor mounting surface must be free of all burrs and debris. This can be accomplished with a wire brush on a drill motor, and if any stubborn areas are left, they can be cleaned with emery paper. Select the largest bell clamp that references the rotor surface that contacts the hub on the automobile. As you can see, this bell clamp is too large. It is important that the bell clamp sit flat on this surface for proper alignment, providing a rigid setup for machining. The brake lathe should be in good working order and properly maintained. The lathe arbor taper should be clean and torqued into the spindle taper at 55 foot-pounds of torque. With the shoulder on the arbor clean, now you are ready to begin mounting the rotor. Place the proper bell clamp on the arbor first. Next, choose a taper cone that will center the rotor and install it on the arbor. The tapered part of the cone must fit in the center hole of the rotor. The same size bell clamp that was used on the inside of the rotor must be used on the outside of the rotor. Now choose the largest radius cones to space out to the end of the arbor and secure with the arbor nut. Note that the arbor nut has left-hand threads. A slow, steady pull should be used to tighten. Make sure you install a rotor silencer as an anti-chatter device. Using the drum feed hand wheel, position the carriage at its full travel toward the arbor and back off 2 revolutions. Make sure the top of the dovetail way is free of debris and burrs. If necessary, a honing stone and some WD-40 can clean any debris or burrs. Now, using the rotor feed hand wheel, position the carriage to its full travel away from the machine. Place the T-bolt in the dovetail slot and install the rotor truer so the tool bits are centered on the rotor. The front edge of the rotor truer base should be approximately 1/8 of an inch back on the dovetail way. Never allow a tool bit to contact the rotor unless the rotor is turning. Tool bit damage could occur. It is now time to turn the lathe on. Notice that when the switch is in the rotor position, there is no power going to the drum feed motor. This eliminates the possibility of accidentally damaging the customer's rotor. Next, determine if the carbide tool bits will machine the entire surface area of both sides of the rotor. It may be necessary to use a zero-angle tool bit holder on the left side of the rotor. This tool bit holder should be pulled in as close to the square bar holder as possible, and the right-hand tool bit holder should be slightly extended. Once full travel of surfaces has been obtained, the carbide bits should be positioned just behind the ridge on the outside of the rotor and fed in until they contact the rotor a full 360 degrees. At this time, both rotor adjusting knobs should be zeroed. It is advisable at this stage to hand feed the cutter assembly backwards to cut the outside ridge of the rotor. Back off each knob 1 full rotation and position the tool bits halfway across the surface and feed the bits in until they make contact a full 360 degrees. If each tool bit contacts 360 degrees before reaching 0, it will not be necessary to change the 0 setting. If not, 0 must be re-established. Of course, if a deep groove is apparent, then the 0 setting should be obtained by getting 360-degree contact in the bottom of the groove. Continue turning the hand wheel to position the tool bits toward the innermost surface of the rotor. Adjust the tool bits back to 0, then add another 2 to 3 thousandths. This will ensure machining of all surfaces in one pass. Now engage the rotor feed lever and machine the rotor. After machining is complete, double-check the rotor for minimum thickness specifications. No rotor may be installed on a vehicle if it is below the vehicle manufacturer's minimum thickness specification. As with any machining setup, all reference surfaces must be cleaned from debris and grease. The hubbed rotor must be set up with the bearing cups as the referenced mounting surfaces. The proper radius cone must be chosen to reference the bearing area in the cup. This can be determined by free pivoting the radius cone in the bearing cup. The radius cone should rotate, free and smooth, in the bearing cup, similar to a ball and socket. The proper radius cone is selected for the inside cup and the outside cup by this same procedure. Any defective cup must be replaced prior to machining. First, the inboard radius cone is installed on the arbor. Next, install the rotor, and then the selected outboard radius cone. Use the largest available radius cones as spacers for the remaining length of the arbor and install the arbor nut. The proper way to tighten an arbor nut is with a slow, steady pull. Turn the lathe on and sight the radius area of the radius cone used to space out the arbor nut. If it is not running true, check the setup. Be careful not to shock load the arbor nut. Shock loading the arbor nut will cause what appears to be a bent arbor and may cause an inaccurate setup and alignment of the workpiece. The rest of the machining procedure is identical to the one used for hubless rotors. With the addition of the non-directional rotor finisher, model number 433179, we can enable you to have the ultimate in surface finish. The rotor finisher is permanently installed on the rear of the lathe and readily available for use. After machining the rotor, simply loosen the square head bolt to pivot the sanding discs into position. Notice that the height of the disc assembly may be adjusted to accommodate the majority of today's rotors. Turn the lathe on for approximately 30 seconds, and the self-aligning sanding discs will provide a professional, swirled, non-directional finish. Notice that no hands are required in the vicinity of this finishing operation. The same two basic setups apply to drums as well as rotors. All of the same conditions, such as debris, burrs, etc., also apply to drums. We will address hubless drums first. The largest bell clamp that will reference the surface of the drum that contacts the vehicle hub should be used. Once the correct bell clamp has been chosen, place it on the arbor. Next, place the spring on the arbor and select a taper cone that will reference the center hole of the drum. Install the taper cone on the arbor and center the drum on the arbor next to the taper cone. The same size bell clamp should be used on the outside as used on the inside. Remember to always use a silencer belt as an anti-chatter device. Use the drum feed hand wheel to position the dovetail way all the way toward the arbor. Insert the T-bolt in the slot on the dovetail way and use the rotor hand wheel to position the dovetail way all the way forward. Mount the boring bar holder on the dovetail way with the boring bar approximately parallel to the spindle. Extend the boring bar through the holder until the tool bit almost touches the back of the drum. While rocking the boring bar in the holder, tighten the square head bolts on the top of the boring bar against the center of the flat. Rocking the boring bar will help center the square head bolts. Back the drum feed hand wheel out until the tool bit clears the edge of the drum. Turn the lathe on in the drum position and place the tool bit just inside the lip on the drum. Using the rotor hand wheel, feed the tool bit in until it touches the drum a full 360 degrees. Using the drum hand wheel, feed the tool bit out to remove the outer lip. Feed the tool bit in to the mid-range of the drum. If the tool bit is not contacting 360 degrees around the drum, increase the depth until it does. Continue to feed the tool bit to the rear of the drum, and if the bit is not contacting 360 degrees, increase the depth until it does. Now add 2 to 3 thousandths of an inch and engage the drum feed lever. The entire drum surface will now be machined in one pass. Remove the drum from the lathe and check for OEM minimum specifications. No drum should be installed if it exceeds minimum set by OEM. The procedure for mounting hubbed drums is identical to that used for mounting hubbed rotors. Make sure the bearing cups are free from debris and grease. The procedure for machining a hub drum is identical to that used in machining a hubless drum. Remember to check the drum for OEM minimums after machining. The setup for machining flywheels is basically the same used to set up a hubless rotor or hubless drum. As always, the contact surfaces on the lathe and the accessories must be clean and free of any burrs. The machined surface in the center of the flywheel must be free of all rust, debris, nicks, burrs, etc. The diameter of this machined surface will determine the size bell clamp to be used in the flywheel setup. The bell clamp must fit within the machined diameter. If the center hole in the flywheel is just slightly over 1 inch, the bell clamp can be eliminated and the flywheel installed directly against the arbor shoulder. If the center hole in the flywheel is smaller than 1 inch, the small hole flywheel adapter, model number 434775, should be used. After making sure all contact surfaces are clean and free of burrs, mount the selected bell clamp. Next, install the spring and proper centering cone, and mount the flywheel with the flywheel friction surface facing the lathe housing. Use the same size bell clamp on the outside of the flywheel as used on the inside. Space out to the arbor threads using the largest available radius cones and install the arbor nut. A visual inspection with the lathe running should show if the flywheel is running true. If not, check the setup. Magnets available at most industrial supply outlets attached to the outboard side of the flywheel work well as anti-chatter devices. The heavy-duty boring bar, model number 434469, should be used for all flywheel machining. Position the drum feed dovetail way so it is fully extended and then back off 2 complete rotations. Install the boring bar on the lathe with the square head bolts loose and the boring bar fully retracted. Position the rotor feed dovetail way as close to the lathe housing as possible. Now, position the carbide bit with the leading edge of the bit forming a 90-degree angle with the face of the flywheel. If a 90-degree angle cannot be obtained, get as close as possible. Secure the boring bar holder to the dovetail way and the boring bar in the holder. Turn the lathe on by placing the switch in the rotor position. Locate the deepest wear or groove on the flywheel and set the tool bit 15 thousandths deeper when adjusting the depth of cut for the flywheel. Engage the rotor feed lever and machine the flywheel. When machining a 2-step flywheel, care must be taken to remove the identical depth of material on both flywheel surfaces. As you have seen, the AccuTurn Model 8922 can handle a variety of applications. In addition, we offer a wide selection of adapters and accessories for most every brake lathe need. With proper maintenance, the 8922 will provide you years of quality service. If you have any questions regarding a special application or technical service, please call our technical hotline at 1-800-551-ACCU. We look forward to hearing from you.
Congratulations on your choice of the world's finest, most versatile, and most accurate on-the-car disc brake lathe. Your new AccuTurn OCL represents the culmination of nearly a decade of development, testing, and improvement. Made from top-grade materials, the components of the AccuTurn OCL are precision machined and fully hardened for maximum accuracy. Each machine is engineered for reliability and the longest service life possible. Your AccuTurn OCL will continue to save you time, help you do better quality brake service, and make you money for many years to come. The first thing to do when you receive your AccuTurn OCL is to complete the warranty registration card and mail it in. This will not only ensure that your purchase is registered for any warranty service or parts it might require, but it will also help us to notify you with any future product modifications or helpful application information. We also urge you to fully read the operator's handbook. Most of the typical questions relating to installation, application, technique, maintenance, and troubleshooting are all covered in your handbook. We recommend keeping it handy in your carrying case for ready reference whenever it's needed. Why machine rotors on the car? First, some rotors are difficult to remove and difficult to reinstall properly. On some cars, rotors are mounted inboard behind the hub. Some four-wheel drive rotors must be totally disassembled to remove, and some cars have special pressed-on rotors and bearings. In cases like these, on-car machining provides obvious substantial labor savings. But even on easy-to-remove rotors, the main advantage to the AccuTurn OCL system is precision. The AccuTurn OCL can give you the accuracy you need to eliminate lateral runout problems, brake vibrations, and costly customer comebacks. By mounting to the caliper bracket using a fixture that is completely rigid to resist any flexing or deflection, rotors will be resurfaced completely parallel, with no lateral runout problems. What's more, the process requires no dial indicators or compensation by the operator. The first step in installation and application of your lathe is to dismount the wheel. On outboard mounted rotors, refasten the rotor to the hub using the special countersunk washers supplied. Remove the caliper and suspend it back out of the way. Before attempting to machine the rotor, it is of course absolutely essential to ensure the rotor has not been worn or damaged beyond the minimum allowable thickness. Check with the brake rotor micrometer and replace the rotor if necessary. If the rotor is acceptable, your next step is to inspect the wheel bearing. If there is any apparent play or roughness, now is the time to repack or replace bad bearings or CV joints on the front-wheel drive cars. You cannot machine a rotor on a defective wheel bearing and expect proper results. Bad bearings represent a potential for comebacks and a safety hazard, but they also represent an opportunity for additional sales. Now take a moment to look at the caliper mounting lugs to make sure they are clean and to determine the best mounting method for the lathe. Your AccuTurn OCL is very versatile with many mounting alternatives, so you can always find a suitable method. One side of the lathe has threaded mounting holes and the other has unthreaded ones. In your carrying case, you also have threaded and unthreaded mounting plates. Depending on the make and model of the car, some caliper mounts are threaded and some are unthreaded. In general, on unthreaded caliper mounts, you will use the threaded mounting plates fastened to the inside of the unthreaded holes on the lathe body. Conversely, when faced with threaded caliper mounts, it is usually easier to use the unthreaded plates fastened to the outside of the threaded holes on the lathe. Before attempting to mount the lathe, ensure that the tool bits are fully retracted to avoid accidentally damaging them during handling. Release the lathe feed clutch and, turning the hand wheel counterclockwise, withdraw the tool slides to the outermost position. With the appropriate mounting plates loosely fastened to the lathe body, center the lathe over the rotor and select the appropriate shim washers so that the rotor will be approximately centered in the throat of the lathe when mounted. The AccuTurn OCL provides a wide selection of mounting hardware and accessories to give you maximum mounting flexibility. Install the lathe to one of the caliper mounts using the original caliper mounting bolts, with your selection of shims mounted between the caliper mount and the connecting plate. Recheck that the lathe is properly centered, add or change shims as required, then install the remaining shims and bolts. Before tightening, adjust the angle of the lathe so that the bit travel will be approximately along the imaginary line through the center of the axle. Release the lathe feed clutch and check that the lathe can make the full travel without hitting any obstruction. Reposition the lathe in different mounting holes if necessary, then tighten all fasteners firmly and you're ready to begin machining. While it is possible to use the car's engine for turning rotors, to get the best results from your AccuTurn OCL, we strongly recommend the 8710 auxiliary drive and storage stand. You will be able to achieve a better quality finish since the 8710 will turn the rotor at the correct steady speed. Also, the 8710 drive unit will provide considerable convenience and safety advantages. You will not have to climb up and down from the car to stop or start the engine, adjust idle, engage or disengage gears, etc., or risk engine overheating or bit damage due to excessive speed. With the 8710, you will have full control of the rotation and direction right at hand, ready to start or stop instantly. In addition to controlling the rotor speed and direction, the drive unit has several other convenience features and benefits. 2 electrical outlets are provided which can be used for connection of the power feed and the work light, often important when working in the wheel well. There is no need to pipe away exhaust gas or lock the opposite wheel, nor is there any chance of damaging CV joints. For convenience, a handy storage tray keeps your lathe and all accessories close at hand, not hidden in a drawer or under a bench. The whole system can be quickly and easily wheeled into position or put away in one trip. There's nothing to lift. Using the auxiliary drive is easy. The patented coupling and yoke is designed for universal application, regardless of the number of studs or bolt pattern. The yoke fastens to the rotor or hub by means of a single fastener with the V-notch against the axle. In this way, the crossbar is always positioned directly over the center of the hub. After the yoke is installed, rotate it so that the crossbar is horizontal. Wheel the drive stand into a position so that the output shaft is approximately in line with the axle. Release the locking screw on the center shaft and raise or lower the power head by using the large wing nut until the shaft is at the same level as the crossbar. Note that the locking clamp handle is equipped with a spring-loaded release to allow you to fully adjust its position without worrying about clearance. To release the clutch, pull the handle outward and reposition it to the desired orientation. A spring will re-engage the clutch, and you can fully tighten or release the center post lock as desired. With the opening of the coupling in a horizontal position, push the drive unit forward, engaging the coupling until the crossbar is approximately 1/4 inch from the back of the slot in the coupling. Then lock the rear caster. Note, leave a clearance of at least 1/4 inch to 1/2 inch at the back of the coupling. This clearance is absolutely necessary to allow for any slight misalignment. Turn the crossbar to the vertical position, testing for any apparent binding, and see that the coupling still fits loosely, not pressing hard against one side. Adjust the angle if necessary and recheck that the crossbar hasn't bottomed in the coupling slot. If it has, release the rear caster, pull the drive unit back slightly, and relock it. Recheck that the height is correct when the crossbar is horizontal and that there is no apparent binding during rotation. Then turn on the motor in the direction of the arrow on the lathe body and check that it runs smoothly. If there is excessive shaking or oscillation, a slight upward or downward adjustment of the drive unit height using the large wing nut will normally smooth out the rotation. Since the patented coupling and yoke design functions as a simple universal joint, the only critical adjustment for smooth operation is the height adjustment, as long as the clearance has been left at the back of the opening of the drive coupling. Once the drive unit is running properly and smoothly, tighten the locking lever, plug in your work lamp and power feed, and you're ready to proceed with machining. Start the drive unit motor in the appropriate direction, or start the car engine and engage either first or reverse gear to match the rotation to the direction of the arrow on the lathe body. This is very important since any attempt to machine using the wrong rotation will damage the rotor and the tool bits. With the rotor turning in the right direction, with the feed clutch disengaged, bring the tool tips to a position just inside the rusted outside edge of the rotor. Carefully cut away the rusted outside edge to a depth close to that of the braking surface. Then position the tool bits over the lowest point of the braking surface. Feed in the bit holders until the tips just touch the surface for 360 degrees. Note the reading on the tool bit knobs. Retract the tool bits a few numbers. Each number on the tool adjuster knobs represents 1/10 of a millimeter, or 4/1000ths of an inch. Turn the hand wheel clockwise until the tool tips approach the center hat section of the rotor. If the rotor is badly worn out of parallel, you may find it faster to carefully hand machine the rotor surface. Once you are just past the inner braking surface, turn the adjusting knobs back to the original reading, plus an additional 1/2 mark. Set the power feed switch to position 2 toggled to the rear, to start the hand wheel rotation counterclockwise when viewed from the rear of the lathe. Turn the clutch knob in to engage the feed, and the tool bits will be steadily, slowly drawn toward the outer edge of the rotor. The steady, smooth feed and rotation provide a high-quality surface finish. After the lathe has made a full cut, the lathe continues to feed to the end of the tool slide travel, where the clutch will simply slip until the motor is turned off. If the braking surface has not been fully machined, the process can be repeated. Release the clutch, back off the bits one number, return the tips to the inner position, and once again turn the tool bits up to a maximum of 2 numbers, depending on the amount of material that still has to be removed. For the best quality finish, 1 number, or 4/1000ths of an inch, is recommended. Re-engage the power feed clutch to complete machining. After machining is complete on both sides of the rotor, recheck the thickness using your micrometer. Since the Accuturn OCL cuts in exactly the same position as the caliper mounts, both surfaces of a rotor will be parallel, and lateral runout problems will be eliminated. Now you can machine the rotor on the opposite side of the car. Using the same mounting adapters and shims, reinstall it on the opposite side caliper mounts. Note that the rotation of the rotor will have to be in the opposite direction to follow the arrow on the lathe body. After machining the rotors and removing the lathe, the braking surfaces may be dressed to remove any directional pattern. A convenient method is to lightly apply an 80 to 120 grit sanding disc to the braking surface with a drill while the rotor is turning. This will provide the desirable non-directional finish to eliminate brake clicking and is recommended for semi-metallic pads. The result is a perfectly machined rotor, completely parallel with no lateral runout problems for quiet, smooth braking, just what the customer wants. In fact, even if you have installed a new rotor on the car, you owe it to yourself and your customer to check that lateral runout is within acceptable limits. If necessary, your Accuturn OCL can put a finished cut on the new rotor to overcome any mounting error, thus avoiding potential costly comebacks. Your Accuturn OCL comes equipped with a wide range of standard mounting accessories for different types of automobiles. For even greater flexibility, Accuturn offers 2 optional accessories. The Ford slider adapter drops into the center of the lathe and bolts directly to the unthreaded holes in the lathe body. Attachment of this adapter allows machining of Ford slider-type calipers. The 4x4 adapter is designed to replace the standard drive yoke connecting the rotor to the power drive unit. It bolts in place in the same manner as the standard yoke, but is machined with extra clearance to accommodate the longer 4-wheel drive hubs. The Accuturn OCL is designed for years of reliable performance and minimal maintenance costs. For best performance, we recommend periodic lubrication with a light machine oil, specifically in the areas of the tool slides, tool bit holders, and drive screw. Moving parts should be kept free of debris, and tool bits should be replaced if worn or damaged. Following these simple steps will ensure you years of precise, trouble-free operation. We appreciate your confidence in the Accuturn OCL system. We know that your investment in Accuturn will be a profitable one for many years to come. No one ever regrets buying the best there is.